Okay, lesson 5.1, midpoint, distance, and spherical geometry. In this video, you will learn how to find the lengths or distances of line segments, find the midpoints of line segments, and find specific partitioned points on a segment, all on the coordinate plane. Now, we did discuss the differences between spherical and Euclidean geometry in this lesson, and refer to your notes about that, and there was also a handout on spherical geometry. Example 1. In this example, you will review how to use the distance formula to find the length of a line segment. Segment UV has endpoints at U, -7, 5, and V, 4, -3. Find the length of UV. Round your answer to the nearest tenths place. So we want to find the length of this segment on the coordinate system. We're going to be using X and Y coordinates in ordered pairs to do this. From Algebra 1, you should have learned the distance formula and how to use it a little bit. So this will be a little review. So to find the distance, we use the distance formula. The distance formula says that you take the square root of the difference of the X coordinates of the two endpoints squared, and you add to that the difference between the Y coordinates squared. And so there you have the formula. So we need to assign values to both endpoints U and V. It doesn't matter which one you start with as long as you remain consistent. If I want to let U be my first point, it has to remain my first point, and V is my second point. It has to be that way through the whole problem. So that means -7 would be my first X coordinate, and 5 would be my first Y coordinate. 4 over here would be my second X coordinate, and -3 would be my second Y coordinate. Now we're set to go. Two ways you can show distance in geometry. You can either use, we were talking about segment UV, so you can say the length of UV, or you can say the distance of segment UV, seeing it that way. So we take the formula, square root's nice and long there, make sure it goes over the entire expression. X2, which is 4, minus X1, which is -7, squared, plus. Back over to Y2, -3, minus Y1, which is 5, squared. Alright, then using the order of operations on this, we have the square root of 4 minus -7 is 4 plus 7 squared, plus -3 minus 5 is -3 plus -5, which is -8 squared. Then we have 4 plus 7, which is 11 squared, plus -8 squared. Now, notice I put -8 in parentheses. Is this important? Yes, it is. Please note, very important here. In your calculator, if you were to key in -8 and then square it, you're going to get -64. However, if you keyed in parentheses around that -8 and squared it, you're going to get +64. Two very different values. Always remember to put parentheses around any negative value that you're going to square. So be very careful of that. Back to the problem. We have the square root of 11 squared is 121, plus -8 squared is +64. Then we add those two. That gives us the square root of 185. So the length of UV is approximately equal to, take your calculator, put in the square root of 185. You're going to get about 13.601471 and so forth. They want us to round to the tenths place. Look at the next place to the right, which in this case is the hundredths. If this is 0 through 4, this tenths place number digit stays the same. If this is 5 through 9, this has to be pushed up 1 to 7. So therefore, rounding to the tenths place, we have about 13.6 units. So the length of segment UV is about 13 6/10 units long. Okay, example 2. In example 2, you will review how to use the midpoint formula to find the point that's halfway between the endpoints of a segment. Segment EF has the endpoints at E 7, 5 and F 2, -4. What are the coordinates of its midpoint, M? So our midpoint is going to be somewhere in the middle, of course, because the definition of midpoint is the point that divides a segment into two congruent parts. So they want us then to check our work by graphing it, so we'll do that. So we're going to find the midpoint. The midpoint formula is the ordered pair x1 plus y1, x2 over 2, comma, y1 plus y2 over 2. So for this particular problem, we have the midpoint of segment EF, and we need to assign values to both our endpoints, just like we did with distance. I'm going to let E be my first point, F be my second point. Therefore, 7 is x1, 5 is y1, and over here 2 is x2, and -4 is y2. So now we're ready to substitute in. x1, 7 plus x2 is 2 divided by 2, comma, y1, which is 5 plus -4, which is y2 divided by 2. So the midpoint of segment EF is 7 plus 2 is 9/2, comma, 5 plus -4 is +1/2. Now, this is a perfectly acceptable answer, and it's probably preferred by most. However, since this problem did not say what form to put your answer in, it would also be acceptable to use mixed numbers. It would be acceptable to use decimals, but please make sure that if you're going to use decimals, everything's a decimal. If you're going to use fractions, everything's a fraction. So you could have written 9/2 is 4.5, comma, 1/2 is your answer. Or it's all decimals, that would be 4.5, comma, 0.5. I'm going to use this to graph because you need to know how to graph fractions. So start at 0, 0. This is positive 9/2 in the x direction. Look at the denominator. It happens to be 2 or halves. That means each full unit gets cut into 2 equal parts, and you start counting each of those parts. So 0 halves, 1/2, 2 halves, 3 halves, 4 halves, 5 halves, 6 halves, 7 halves, 8 halves, 9 halves is right there. And then from there, we go up positive, up 1/2 unit. This is one full unit, go up 1/2 unit, and you end up right there. This is M, the midpoint. So ME and MF are congruent. Anyway, there's the graphical picture of that. Example 3. In this example, you'll learn to find one of the endpoints of a segment given the other endpoint and given its midpoint. So we're going to use the midpoint formula, except we're going to use it in a pretty different way. Segment RS has its midpoint at 4, -2. So we're given the midpoint. One of the segment's endpoints is at S 3, 6. So we have one of the endpoints. They want us to find the other endpoint R of that same segment. Now I didn't put this on a coordinate grid or coordinate plane because I wanted you to focus in on the numerical part of the problem. But I did want to put this on here so you kind of get an idea what's going on. The midpoint is at 4, -2. Here's the midpoint of RS. So this would be R and this would be S. They gave us the endpoint S, which is at 3, 6, and we don't have R, and I allowed R to be my first point because I've got these sub 1s here. So that means 3 is going to be my x2 and 6 is going to be my y2, because remember, these are the endpoints, so they get the 1s and the 2s labeled on them. The midpoint, this is simply our x coordinate for a midpoint and our y coordinate for a midpoint. Okay, so now that we have got that kind of set up there, let's go ahead and use the midpoint formula. The midpoint of RS, segment RS, is x1 plus x2 over 2, comma, y1 plus y2 over 2. And what we're going to do is we're going to split this off into 2 equations. Since this is an ordered pair, it's got the x part and the y part. Well, the midpoint has an x and a y value also, so whatever the midpoint's x value is, it goes with the first part, and whatever the y is goes with this one. So the midpoint x-coordinate x, so that would be the midpoint of the x-coordinate is x1 plus x2 over 2. And for the y part of this, we have the midpoint y-coordinate equals y1 plus y2 over 2. Now, once we've done the split off here, we can start substituting in values, and what we're going to do is we're going to end up finding the x-coordinate and the y-coordinate of R. So, the x-coordinate of the midpoint is 4. We substitute that in. That equals x1, which we are looking for, plus x2, which is 3, over 2. So we have this equation. And the y-coordinate of the midpoint is negative 2, and that equals y1, which we're looking for, plus y2, which is 6, over 2. So now we have these two separate equations, one to find x value, one to find the y value. Well, when we have an equation with any fractions in it, or a fraction, we get rid of that fraction by multiplying out the denominator. And it just happens to be one denominator here. So if we multiply the entire right side by 2, the 2's will divide out. But if we do that, we have to do it over here. We have to multiply by the exact same thing. So this 2 times 4 is 8 equals x1 plus 3. The 2's divided out, and here's our new equation. Over here, we do the same thing. We have a 2 here. We want to divide it out. So we multiply the right side by 2. They divide out. Multiply the left side by 2. 2 times negative 2 is negative 4 equals y1 plus 6. The 2's are gone. Now all we have to do is solve for each one of the variables. If we subtract 3 from both sides, x1 is going to be 5. Subtract 6 from both sides over here, y1 is going to be negative 10. Therefore, R, which was at x1, y1, the endpoint, is, we found it, 5, negative 10. So it's 5, negative 10. Okay, example 4. This is a type of problem you've probably never done before, at least in Algebra 1. But in example 4, we want to partition. You're going to learn how to use a formula to find a specific point on a segment that's a fraction of the distance from one endpoint to the other. When we were doing the midpoint, that was half the distance from one point to the other. Well, this is like that, except it's a little bit more complex because we're not going to be looking for halfway across the segment. We're going to be looking for a different fraction. There is a formula. We went over that on our lesson for this. And I'm going to show you how to use it. Example 4, find point T that's 3/4 the distance from P to Q, point P to Q. So starting here, we're going to go 3/4 the distance to Q. Of course, it's going to be somewhere in here. If we were starting at Q and going from Q to P, it would be in a different location. So this is real important for you to notice from which point you start. We're going to do that if the endpoints of segment PQ are at P, -6, -2, and Q, 3, 4. And then they want us to graph the result. Okay, so we get started. What we do is we need K. K is, well, let's go ahead and write the formula down. T, what we're looking for, is an ordered pair. I'm going to start with brackets. Is K, small k, times the difference between the x coordinates. x2 minus x1 plus x1, comma, and then K again, times the difference in the y coordinates, y2 minus y1 plus the y1 coordinate. So here's your first coordinate, the x coordinate. This is going to be your second coordinate, the y coordinate. This is going to be an ordered pair, so we know where to put our point that's 3/4 the distance from P to Q. Now, T is what they named it. That's why we have T here. So T is equal to K. What is K? K is the partition ratio or partition fraction. It's the amount of distance, the fractional distance we're going to move. So here it is right here. Here's little k, small k. So we have 3/4 times, we need to have values for both of these. So let's let P be our first one. Now it's important that we let P be our first one because we're going from P to Q. It's not like with the midpoint or distance where it doesn't matter. We're going to have to start with the one that they want us to measure from. And then Q will be our second point. So that means -6 is the x1 and -2 is y1. Over here, 3 is going to be x2 and 4 is going to be y2. So x2 is 3 minus x1, which is -6, plus x1, which is -6, comma. Put it in just as you see it, so that you don't make any mistakes. K again is 3/4 times y2, which is 4, minus y1, which is -2, plus y1, which is -2. Close bracket. Okay, from this point, we start using the order of operations. We can get this down to one single ordered pair. Starting in the parentheses here, 3 minus -6 is 3 plus 6, which is 9. So 3/4 times 9 plus -6 is -6, comma. 4 minus -2, we got our 3/4. 4 minus -2 is 4 plus 2, which is 6. So 3/4 times 6 plus -2 is -2. Okay, taking 3/4 of 9. Unfortunately, 9 doesn't divide out with any factors of 4 at all. So we're stuck with 3 times 9 is 27 over 4 times 1 is 4 minus 6, comma. Over here we have a factor that divides out with 4 and 6. 4 and 6 are divisible by 2. 2 goes into 4 twice, 2 goes into 6 3 times. But we still have a number down here. We have 3 times 3 is 9. 2 times 1 is 2. 9 halves minus 2. And then we're subtracting, so we need a least common denominator here and here. And they have to be 4 here and 2 here. So we have 27/4 minus, we need that to be in fourths. So 1 times 4 is 4, so 6 times 4 is 24. Over here we have 9 halves minus, we need 2 in halves. So 1 times 2 is 2, so 2 times 2 is 4. We're almost there. 27/4 minus 24/4 is 3/4. 9 halves minus 4 halves is 5 halves. So this is the point T, let me put it in parentheses now, 3/4, comma 5 halves is 3/4 the distance from P to Q, point P to point Q. Now we're going to graph it. Starting at the origin, 3/4. That means we cut the first unit up into 4 equal parts and we go 3 of them. 1, 2, 3, right about there. Then we go up, positive 5 halves. Cut each one unit into 2 equal parts. So that's 1 half, 2 halves, 3 halves, 4 halves, 5 halves. And so this point right here is T, 3/4 the way from P to Q. It even looks that way. Example 5 is just like example 4. I'm going to let you stop the video and do it yourself now, and then I'll go over it. Okay, so for example 5, you're going to practice using the partition formula again. Find point P that's 2/3 the distance from L to M. There's L, there's M. If the endpoints of LM are at L, -4, 1, and M, 5, -5. Graph the result, just like last time. I'm going to go ahead and get these values on my points here. So L, I've got to let L be my first point because we're going from L. M is going to be my second point. So that means this would be x1, y1, and this would be x2, y2. This time we're going to, instead of t, we're going to use p, because that's what they named the point that we're looking for, is going to be, and I'm going to go ahead and use the formula directly. We have 2/3, which was k, times x2, which is 5, minus x1, which is -4, plus -4, which is x1, comma, and we have 2/3 times, and then for our y's we have -5 minus +1, and then we add the y coordinate for the first point, 1. There's that. Hopefully you got that right. Let's continue on. Alright, so starting with 2/3 times 5 minus -4 is 5 plus 4, which is 9. Plus -4 is -4, comma. Now we have 2/3 for our y coordinate. We have 2/3, and then -5 minus 1 is -6, plus 1. So point P, our partition point, is 2/3 times 9. Well, here 9 and 3 divide out, or at least the 3 does. 3 goes into 3 once, 3 goes into 9 3 times, and we have 2 times 3 is 6, over 1 times 1 is 1, and 6 over 1 is 6 minus 4. 2/3 times -6, don't forget your negative. 6 over 1, 6/3 also reduces or simplifies, divides out. 3 goes into 3 once, 3 goes into 6 twice. So we have 2 times -2 over 1 times 1. That gives us -4 plus 1. So 6 minus 4 is 2, and -4 plus 1 is -3. This time we got 2 whole numbers for our coordinates. Should be easy to graph. Start at the origin, go to the right 2, down 3. 1, 2, 3, and this point right here is point P, which is 2/3 distance from L to M. Right here, 2/3 the distance. Example 6. In example 6, you're going to learn how to verify and test a conjecture or mathematical statement by using properties of figures on the coordinate plane. Recall that a rhombus is a parallelogram whose sides all have the same length. The diagonals of a rhombus happen to intersect each other at their midpoints. Use the distance formula to check that all sides of rhombus ABCD are congruent. All these are congruent. We want to check to see if they are. Then use the midpoint formula to check to see if the diagonals intersect each other at the same midpoint. So then we'll use the midpoint on the 2 diagonals to see if they're meeting at the same place. One of the main focuses here when you're doing a verification like this on the coordinate system is that you try to use geometric and mathematical language as much as you can, or the symbols for them. So concentrate on substituting words with logic or geometric symbols as much as you possibly can. So again, rhombus is a parallelogram, and all the sides should be congruent. So we're going to check the sides first. Sides congruent. So we're going to start with AB, the length of AB. We're going to have AB, we're going to look at BC, CD, and DA. So let's get these ordered pairs down. A is at -2, 0. B is at -1, 4. C is at 3, 5. And D is at 2, 1. So now I'm not going to put X's and Y's on all these because they're going to change each time. If you need to do that, you go ahead and do that. But so AB, remember the distance formula. We're going to find the lengths, or we're going to show that all the lengths are the same because we're going to use the distance formula on all 4 of them. So we have, instead of writing the formula down, I'm just going to go ahead and plug everything in. I've got AB, so I'm looking at these 2 right here. I'm going to start with, I'm going to let A be my first point, B be my second point. So this would be x2 right here. So I'm going to start with a -1. So this would be -1 minus -2 squared plus, and then for the y's, we have 4 minus 0 squared. So then we have Negative 1 minus negative 2 is negative 1 plus 2 squared plus 4 minus 0 is 4 squared. Then we have square root of, that's negative 1 plus 2 is 1 squared plus 4 squared. Now we square. 1 squared is 1 plus 4 squared is 16, and we get the square root of 17. Now you can write this as an approximation if you'd like, but I'm going to leave mine as the square root of 17. Okay, next, BC. Now, if the rest of these are the square root of 17, then we do have a rhombus. It looks like we have one. This will be the square root of, this time we're using B and C. So this one and this one, I'm going to let C be my second point. So I'm going to start right here and move back over to this one. So that would be 3 minus negative 1 squared plus 5 minus 4 squared. Those are the y's. And that gives us 3 minus negative 1 is 3 plus 1 squared plus 5 minus 4 is 1 squared. So then we get the square root of, that's 3 plus 1 is 4 squared plus 1 squared. And we square, and we get 16 plus 1 under the square root, and that gives us the square root of 17 again. That's good so far. CD, same thing. I'm going to use these 2 points right here. I'm going to start with the 2 and move back over to this other point. So we have 2 minus 3 squared plus 1 minus 5 squared, those are the y's, equals the square root of, we have 2 minus 3 is negative 1 squared, don't forget your parentheses around the negative, plus, and then again 1 minus 5 is negative 4 squared in parentheses. Then when we square negative 1 we get positive 1, when we square negative 4 we get positive 16. And 1 plus 16 is 17, so the square root of 17. Looks like we're going to get a rhombus. Let's do one more, AD. The last two. It's right here. So I'm going to start with the D and move over to the A. So I'm going to start with this one. So we have the square root of, using the distance formula, 2 minus negative 2 squared plus, and then for the y's we have 1 minus 0 squared. This gives us the square root of 2 minus negative 2 is 2 plus 2 squared plus 1 squared. And then we have 2 plus 2 is 4 squared plus 1 squared is 1, or 1 squared. And then we get the square root of 16 plus 1, which gives us the square root of 17. Now if any one or two of these had not been the same, then this would be a rhombus. So we would write something like this. Therefore, AB equal BC, which equals CD, which equals AD. Now for the second part, we're going to use the midpoint formula to check and see if midpoint of BD, which is this diagonal right here, and the midpoint of diagonal AC, which is this one right here, ends up being the exact same point, equal. So we're going to use the midpoint formula. And so that means we're going to use AC is right here, these the 2 points for A and C, and for B and D, these two right here. So for B and D, remember it's x1 plus x2 over 2 and so forth. So I'm going to start with the negative 1 for BD. Here we go. The ordered pair, negative 1 plus 2 over 2, comma, and for the y coordinates, 4 plus 1 over 2. Let's see if that equals the midpoint for AC. For AC, I'm going to start with the negative 2 first. We have negative 2 plus the x-coordinate of the other one's 3 over 2, comma, and then 0 plus 5 over 2. Let's see if these work out to be the same. Negative 1 plus 2 is positive 1/2. 4 plus 1 is 5 over 2. Negative 2 plus 1 is 1/2. 0 plus 5 is 5 over 2. So we end up getting the same midpoint. Therefore, the midpoint of BD is equal to 1/2, 5/2, which is also equal to the midpoint of AC. All of this is what you show on your paper to verify or show. that it's true.